It's because it's not the same variable name. Okay, now the fun part. So we want to associate a note per data point, and we're going to pass in that data through this helper function. So data to pitch tuned, put in the argument, put in the parameter fatality count. So how would the data sound? You gotta ask these questions. How do you want it to sound? Or is this data in relation to the pitch? So figure out a major scale or any scales. You can create any scale you want. So yeah, if that's something that you're interested in too, just reach out to me and yeah, we'll figure out if you want to make a scale. Right now I'm using D minor, so in that scale, this includes these notes: D, E, F, G, A, B flat, and C. And then we're going to pick a scale. Or we're going to map a data point to a note. And the MIDI library takes in 2 arguments for that, which is the scale and the scale point. So let's call that class, call the properly scaled note, pass in the scale point, and pass in the actual scale area. So this scale point is where a little magic happens that the library does. So my MIDI has linear scale and logarithmic scale point counters. So right now it's taking in 3 values, but I think there's 4 values they can take in overall. So in this particular one, dot linear scale PCT, it's taking in 3 values. The first one is 0, which is the min fatality count, and the data point 30 is the max fatality count. Now, like I said before, 30 is not the actual max. It's just the range of how many values are within that area. So I don't see a lot of 1700. That's an outlier, even though that's max, so I'm not going to put that. It's just the song's not going to come out well. But you can try it. So I'm going to print that note. Oh, and also, like, fatality count is the value that is being scaled. So you pass in the fatality count in there, and it finds a value for fatality count, and then it scales that based on the scale that you provided and turns that into a note. So it's B flat 6. Okay, we want to translate that note that we just made into a MIDI pitch. So we say MIDI pitch and call the library again. It has a function called .note to MIDI pitch and we pass in the note. And then we're just going to return the MIDI pitch. And now we have it. Now we have a note. Okay, time to make the actual song. So this is a list that contains all the notes. And then we're going to loop through our data and create a note for each data point. So we're going to append that to the song list. I'm just going to reference that little snippet I wrote earlier. This is how you write a song in MIDI time. So remember, time, pitch, velocity, duration. So we want the time first. So in my data time, we're just going to get the beat from there, minus the starting time. Then the pitch is, we call that function, and we convert the fatality count to that pitch. Then we're just going to add a global velocity, 90. And we're also going to add a global duration, which is 2 beats. So now we have a list of notes. So and finally, we're almost there. We're going to add a track with those notes. So we're going to call a MIDI library again. Add that track, the list of notes, and then we're going to output that, write that into a file. Cool. Now head over to GarageBand and see what that sounds like. Okay, I'm gonna clear these up, and then we're gonna listen to the song we just made. Okay, we'll listen to what this sounds like in the final part of this video. Awesome.